Right. Let's retry that common pressure question, which I was unhappy with at the end. Once you have it open, just let me know. You do. Okay. Now, do you have the answers from earlier? Because when
I want to have a picture, but I have it in the marking scheme.
Good. Sounds good. Okay. So, read carefully the last question. Make sure we got it.
The last question says, determine the final common pressure in the two flaps.
That is all.
And so much.
And the previous part was they opened the valve, the clamp.
Yeah. So the number of moles.
It's the same.
The total number.
It's the same.
And R is the same. But
yeah, here we can say P and P are the same. V is different for this one. R is the same. PV, no, sorry, I forgot my N. N or T. Wait a second. P and that. And B or T. It's the temperature I'm unhappy with. They used 20 Celsius.
And 65. They didn't use it. Oh.
They didn't. They just used the 20.
Yes. Why would they use just one if it says common pressure? I think it's get the pressure of the first one and the pressure of the second one and add them. But that's the pressure of one.
I wonder what would happen if I got the T from here and put into that formula to replace the T. You know what I mean?
T equals then put
yeah. So if I have T equals
BV over
PVB over NB or, then I get PVA equals NA or PVB over NB or. But the P's cancel as well, and I want the P. So it's not that.
شوف السؤال اللي جاب أيوة.
I'm going to multiply this by NB, so I have NB PVA equals NA NB or T. I'm going to try. Look, I'm not happy with how they did it in the answers. I don't think it was right to use 20 Celsius. Now maybe it turns out I get the same answer.
Are you multiplying by
NB here, the left and the right. And here I'll multiply by NA. This isn't going to, is this going to work? This might work. I'm going to minus the equations now, minus them. So this will be NBPVA minus NAPVB equals 0. No, this doesn't work either.
Because the B cancels the B also.
Yeah. Okay,
like determine the final pressure in the two flask. There are two flasks. One flask has temperature and the another flask has the different temperature. And
they opened it.
Yeah, they want you to get the pressure. But to find the pressure, you need to solve in this formula. But you can solve in 20 plus 5 plus 20 pressure for 1.
But they want both of the pressures?
No, they want the common pressure, so they want after the pressure has sort of equalized. Yeah, after you mix them.
So we should use like only one PV equals NP.
Well, if we use only one, we could use only one, but the problem is, I could use one of these, but I'm missing the temperature.
It's a waste of time. Let's choose them.
No.
Only 2 marks.
The same quantity in both?
Yeah. Oh well, we worked out earlier what the quantity is in each, and we worked out what the volume is of each. We know this as well. The only thing I can think of to do at the end is the only way I feel like we can go forward is if we work out the temperature. Now I know how to work out the temperature. The temperature is not that difficult to work out because it's the same gas. But it's not something we've done before. But I can show you it. You can tell me what you think.
But the thing is, that's too much for 2 marks.
It is too much for 2 marks. So what they did is they said P is NA or T over VA basically.
Yeah.
And they used the NA answer previously. The OR is a constant, the VA. But they used the temperature of 20 Celsius.
Which was there in the beginning.
Which is at the beginning. But the problem is,
When you mix
There's
1
no way.
with
Yeah.
5, it will not
Wait,
remain as
wait.
12.
Why are we assuming that it's still open?
Because
well, because it's the next part, no?
Because the
It is the next
one.
one. Okay, release it. But, I mean, what if we overlook that? They did that.
Determine.
Because-
Well, because the clamp is then released.
Because they just went back to the question where both flasks where the temperature was 20.5. That's all they did.
Yeah.
They didn't necessarily look back at the fact that it was released. Maybe that's just what they did.
The only thing I can think of that explains why they did it the way they did it is if they meant to say the clamp is opened and then they said something like,
But
what is the pressure immediately after opening? So before you give the gases time for the temperatures to equalize. Do you know what I mean? This is the only explanation I have for why they still use the 20. That they should have said in the question, what is the temperature immediately after opening the clamp?
Or they
and why did they use the volume of A? They use the volume of both, like the common.
But I have a feeling though, if you calculate the P from this formula, you'll use a different N and a different T and a different V, and you probably get the same answer. You know what? Before we finish it, let's check if we used B, we get the same answer that they get. So if we just open up the calculator here, can you tell me, Iyad, what the NV was? Yeah.
This is total. Plus 4 was NA.
Yeah, if you have total and NA, we can just work it out. Yeah, so what was the total then?
0.0806.
806, and the first one?
0.04875.
4875. Okay, times 8.31 times, and is that 65, isn't it?
Yeah.
Yeah, plus 273.15 over, and what was the volume of B?
The volume of B was 0.64 10 to the 1
That's for B. Let's see if we get the same answer. And we'll put this in 10 to the 5s.
It's 1.4.
It's 1.4.
It's like 1.39, isn't it?
Yeah, 1.4.
But it's 10 to the 5 Pascal.
10 to the 5. Yeah. I think I might have typed in something wrong here. I might have missed my 10. No, I didn't. The volume is 10 to the minus 6? No, 10 to the minus 3, you said.
Yes.
And then they have the answer in 10 to the 5.
Yeah.
No, you said 10 to the 6. One point four 10 to the 6.
It's 1.4 10 to the 5. Yeah.
Okay, I might type something in wrong then. I feel like that's the answer, Musharif. That the question meant to say, what is the pressure immediately after opening the clamp, before it has time for the temperature to equalize?
But many 15
Huh?
when they mark it, they will mark it as they meant, not as they meant.
But I have a chance to write a report where I can say in my report, this was a problem with this question. You know? Yes. Okay, what's the next one then, Musharif? You said it in a question. You were eager.
Go down.
Yes. It's a field question, is it? Right, so let Musharif read it since it's his question. Go ahead, don't be shy.
Define electric field strength.
So, what, do you know the definition? Did you check it in the notes? The electric field strength is the force per unit charge on a particle in a field. So, E, electric field strength, is the force felt on a unit charge in an electric field. Something like this. What's the next part?
You will like it.
I will like it. All right.
Sketch.
Yeah. Sketch what?
Sketch the electric field pattern around the negative point charge.
There's the negative point charge, and the electric field goes like this. There you go.
Determine the electric field strength is at point B, a distance of 3.64 centimeters from a negative point charge of 5.19 microcoulomb in
Okay, so the formula for this one, if I remember it, is yes, but that's if you know the voltage, which we don't. This one is the one that goes KQ over R squared. Or if you want to use the other constant, 1 over 4 pi Q over R squared. Now the K is actually in the formula book at the start. I can't remember. It's like 8.99 times. Do you? I don't know if there's a different K.
No, this is small K, isn't it?
Yeah, it needs to be a big K.
We have one
Yeah, there's another 8.99.
to the 10 power max.
Yeah, and times 5.93 times 10 to the minus 6 over 3.64 times 10 to the minus 2 squared. That's the answer. Let's get that. Are you typing in any else? That's great, thanks. This is B1?
No, this is A. I mean the B1 is
This is A part 3?
Yeah.
Okay.
Yep.
Can I E, right?
Yeah, this fraction here.
Big number. So
Yeah.
402,357
402, 3,
5705.23.
yeah,
Or 5.
yeah, so 1, 2, 3, 1, 2, 3, so that'd be 40 meganewtons per coulomb. Big number? Well, what's the answer?
Oh.
400.
Or 2 times 10 to the 7.
Yep. That's it. That's it. Okay, next part is B part 1. What have we got, Mishri?
Now we have before the
Oh, A part 4 still.
the
Okay.
volume, the Q changed to 9.95. Here,
That's it. Just change the Q.
yeah,
Determine the electrical positive charge of
it's not B, it's AI.
Yeah, yeah. Read it there, Iyad.
Determine the electrical force acting on a positive point charge of 9.95 microcoulomb was placed at point P.
Ah, that one's a bit different because now you have two charges, a positive and a negative, so they're going to attract each other, and the force for that one,
No, it's placed at point P, right?
I heard him, yeah. So you have one here, and one here, and one is negative, and one is positive, and what will happen? So the formula is K Q1 Q2 over R squared. Yeah? Which is 8.99 times 10 to the 9 times Q1 is, we said, 5.93 micro. And what's the other one that they gave us?
9.95 micro.
Over the radius, which is 3.64 times 10 to the minus 2 squared. $400 newtons.
Yeah. Now the
Go ahead.
electron in proton is accelerated from base through a potential divisor of 4.45 kilovolt in a horizontal direction.
So we have the current going this way in the electric field, and the electron is fired across. And the way to do this one is, they want the speed, isn't it? So you say here that the energy here is equal to the energy when the electron is here. The energy at the beginning, there's no kinetic, it starts at rest, there's only potential. And do you remember the formula for potential energy in an electric field? Yeah, that's electric field strength, so you have, it's QED, but the E, as you said, is V over D. So if the E is V over D, then it's just Q charge times voltage V is the potential energy. And that will equal, now what energy will have at the end here? It no longer has any potential because it's reached the end. It only has kinetic. A half m V squared, and the small v would be 2QV over mass of electron square root. Right, so that's square root 2 times electron is 23, and we just said it's 4.45 kilo is the voltage. And what's the mass of electron? Constant number 3, isn't it? Yeah.
Yes.
So we get this pretty big number. Let's put this in kilometers per second. Oh, it's still big. Wow. Okay, 39.6 times 10 to the 6 meters per second. You have the answer there, don't you? The check?
3.95, 10 to the 7.
Yeah, same thing.
10 to the 7.
Yeah, but the decimal point's in a different location.
I got 3.95, 10 to the 13. And I got the original answer and then times it.
Do you square root the answer?
10 to the 7.
And did you remember kilovolts? The voltage is 4.45 kilo.
10 to the 3.
Yeah?
Yeah. Square root 2 times e times 4.45 times 10 to the 3 over mass of electron.
And it's all inside the square root?
All inside the square root. I got a huge number. I timed it by 10 to the 6. I get 3.95, 10 to the 19.
But you should be dividing it by 10 to the 6, because you're trying to figure out what power to put at the end. So you need to divide by 10 to the 6 twice now, because you had it wrong the first time.
Yeah, I went back. It's 13. 10 to the 13.
This is your answer.
Yeah.
Divided by 10 power 6 gives you how many 10 power 6s you need. Oh, I see. Let me go back to the fraction.
Equal. Yeah.
Divided by 10 power 6. Okay, it's okay now. Yeah, I don't know what was happening. It's weird. Okay, what's next now?
What's next?
Determine the resultant velocity of the
We did
electron.
that.
The electron enters the electric field between two parallel plates, 8.8 centimeters long and 2.5 apart.
8.8
No, 8 point, only
8 centimeters long. No, practice your English. 8 centimeters long and
2.5 apart centimeters.
yeah.
With a potential of 130 volts between them.
Yes.
The electron is traveling parallel to the plate
Yeah.
as it enters.
And the speed is still the same. 39.6 times 10 to the 6 meters per second is what I got a moment ago. So it enters this, and
They have a
a picture where it goes down.
No, straight.
Oh, yeah. Yeah, great, yeah. It's fired in here, yeah. So what's the question then?
Determine the vertical displacement of the electron from its original direction at the point where it leaves the electric field between the parallel plates.
Yes. Determine
The vertical displacement
yeah.
of the electron from its original direction at the point where it leaves the electric field between the parallel plates.
So what happens here is this electron will be attracted to one of the plates, but I guess that this is too short for it to reach the plate. So what will happen is it'll be pulled down, but by the time it gets to the end, it hasn't reached the plate. And they want to know what's this distance here. Yeah. So,
The distance until it falls.
yeah, the distance it falls. Yeah. Now, what force is acting on this? There's a downward force here caused by the plate. Do you remember the formula for this force?
QE.
Yes. QE. Do we know the Q?
Electron.
Yes. Do we know the E? Well, we could know it because what's the formula for E?
G over D.
V over D. Now, what is the formula for F?
MA.
So MA equals QV over D. So we could work out the A here actually. The A is QV over MD. So that is constant number 23.
But you want the vertical.
I know, but we would need to know the acceleration vertically to work out the displacement vertically. Right? E times V, which is 130, over M times D, which is 2.25 centimeters. So it's accelerating a lot, actually. Did I get that? QV over D, A is QV over... Yeah, it's a lot. What? Yes? Yes, go ahead, Mr. Sharif. What's your question? No, you sure? Okay. So, this particle is accelerating vertically. So, this should remind you what type of problem in mechanics. Huh? Projectiles, yeah. So, this is UVATS in a horizontal and a vertical.
So we have the A.
UVATS. UVATS. The A is 0 in the X. The S is 0.08. The U is 39.6 times 10 to the 6.
Why? They're getting the question.
Are you going to say to me again they want the vertical displacement? Because I know this.
How did you know the U is 39?
Because it was from the previous part. Because this question continues from the last part. Because it's part 2, isn't it?
Yes.
And the question probably started off with the particle leaves the field and enters a blah 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 or something like that. What did they say at the start of part 2?
There are kind of two different parts to this one.
Okay, we'll read the start of part 2, the very beginning of part 2.
The beginning.
Yeah.
An electron in a vacuum.
That's part 1.
Yeah.
Give me part 2.
The electron enters the electric field between...
Pause. That's enough. The electron enters. So we're talking about this previous electron now enters a new field. Because they use the word enters, what would they have to say to make it seem like a new problem? An electron entered. Grammar. Nobody likes it. Is it okay? You don't seem happy. You seem very unhappy. I understand. Well, how can I help? I can't help. What is the U vertically?
Same.
No. No.
Zero.
Yes. It's only traveling horizontally at the beginning. What's the V vertically? Don't know. What's the A vertically? Minus 9.15 times 10 to the 14. What's the T? Don't know. What's the S? What we want. This is what we're looking for, the vertical distance. Yeah, we get the time here. So we can say S equals U T. So we have T equals 0.08 over 39.6 times 10 to the 6. Then, well, we won't work it out just yet because we'll put it into the other formula. Then here we have S equals UT plus a half AT squared. But I don't care about the UT because it's 0. And the A, it's minus, but it doesn't really matter if we consider it going up or down, so I won't care about the minus. Well, I'll put the minus in. Minus a half A, a half minus 9.15 times 10 to the 14 t squared, which is 0.08 over 39.6 times 10 to the 6 squared. That's the answer. Let's get it. Small number. 1.87 millimeters. Could you check out now, or somebody?
1.87 to the 10 minus 3 meters.
Look how sad you are. I can tell your heart is broken. How can I fix it? You don't like this question, do you?
Yeah, the field.
Feels. Yeah, okay. Is there more?
Yeah.
Yeah, go on.
The term, the direction and the field of the magnetic flux density that would need to be applied between the plates so that the electron does not suffer a deflection but continues in a straight line.
Beautiful.
We are suffering. Why shouldn't the electron
All right.
not suffer?
So look what.
We are human.
I know. There's the electron. This is positive. This is negative. And we said in our picture that the electron is moving down. So there's a force acting here. Yes? Now, if we want to cancel this force, we need to put a force acting up here, which is caused from a magnetic field. So we need to use left hand. What's the direction of the current here? Correct. The current is going this way because the electron is going to the right. So the I is going that way. Now, what's the direction of the force? Up. So what direction do we need the magnetic field? Out. Yeah. Very good. So we must put some magnetic field heading towards us, and this will make a force to cancel this force. How big does this force need to be? Well, it needs to equal this. So this force is caused by the electric field, and the formula for that is or QE. But what's the formula for E? V over D. And does anyone remember the formula for the force caused by a magnetic field on a charge? Q V for velocity times B, which is I think it's the B that they're looking for, isn't it? The magnetic flux density. Yeah. So the B, well, these cancel, is equal to V voltage over D distance times V velocity. That V is for velocity. Now, do we know the voltage? We definitely do. What was it? And do we know the distance between the plates? We do. It's 2.5, wasn't it? Do we know the velocity? It was 39.6 times 10 to the... What was it previously? 10 to the 6. So the B is this. Now I'm put this in milli. 0.13 millitesla. How many marks for that one? Yeah, with the 1 mark for this, and then 1 mark for this. Yeah. Only 2? Oh well, that's life. Is that the right answer?
No.
No, great. What's the right answer?
Oh, yeah. I thought you said this is the final question.
Oh, so hungry. Okay, is there more?
Yeah.
Determine the radius of the circle.
You have only 3 ways of, I mean 2 ways of interpreting.
Determine
I
the
need
radius.
to take your hand.
You're doing a good
That's
job.
not
You're doing a good job. Go ahead, Adnan. Determine the radius of
Of the circular path the electron would follow if the
electric field is
between
turned
the
off. Yeah.
deflection plates was switched off.
Yeah. So now what we have is this. Here's the electron, but there's no longer the electric field, there's just the field, the force from the magnet. And this is going to make it flip in a circle. So the force from the magnetic field, that's equal to QVB. That is now a circular force. And what is the formula for a circular force? But this F is now making it move in a circle. So that's equal to mv squared over r. So we can say QVB equals mv squared over r. And the r is what they were looking for? Cancel. R equals mv over qr. Now, the m we know is going to Q what? Oh, B, thank you. The B, I still have it on my calculator. And the E, the charge is just an electron. The mass is just an electron. And the V is 39.6 times 10 to the 6. No, 8. What was it? 6. Are we sure of it? Super. Okay, so we get 1.7 millimeters.
1.7 meters.
Meters? 10 to the minus 3 meters?
No, 1.7 meters.
So I have a power wrong somewhere. Oh, my previous answer, the calculator didn't know it was milli, so that's why it's off by a factor of 3. So I'll just type it in. What was it? 13 milli? 0.13 milli. Now come back. 0.13 milli. Yeah, 1.73 meters. You're thinking about answering it, aren't you? Good.
Is
there more to this one? That was the last part. How many marks for this one?
2.
But I think this formula for OR is in the formula book. Have a look at the formula book and see if you can see a formula like this.
MV over QV.
Yeah. The formula book's at the start of the exam. Keep going, yeah. Keep going. Wait. Okay.
You're looking for fields, right?
Yeah. Keep going. Press enter. Yes. Yes. I thought it was there. Maybe it's not. Maybe it's just I imagined it or it's in the new version. Just go to the next page. Just see. No.
Magnetic fields, maybe?
Oh. No, not that. There's no point in starting a new question now, and I need to get ready for the labs.
Thank God you said that. How? Are you okay?
No, I'm not, because I'll have 3 hours of labs now with January students,
Okay.
so I need to get some food before that starts.